Meu mengam chicum ens ayo Chinese conformem tianine. Winon, something tinti, something sun some. Biao biao winduni tian pin sun some. There is no memory that carries over. No work happening in the background. Nothing waiting for you when you come back. It is more like a calculator than an assistant. And for a while I accepted that, because that was just how these things worked. Then I got tired of it. I wanted something that actually ran while I was asleep, that kicked off work on its own, that was sitting there with an answer when I needed one, not starting from scratch every time. So I built it. And this video is the honest account of what that actually looks like, what it does, where it falls short, and what I learned keeping it alive, what self-hosted actually means. Before I explain the setup, I want to make sure we are on the same page about what self-hosted means, because the phrase gets used loosely. For me, it means the model runs on hardware I own and control, in my room, not on someone else's server. The data I feed it never leaves my machine unless I choose to send it somewhere. The process runs whether or not a browser tab is open, and if the service costs me money, it is a metered cost I control, not a subscription seat tied to a vendor's pricing decisions. That is the full definition. It is not about being against cloud services. I use cloud services all the time. It is about knowing exactly where the processing happens and owning the hardware it runs on. When you build something that touches your own nodes, your own files, your own schedule, that distinction matters a great deal. When I start building this, the reasons I built it are practical and specific. The first was rate limits. When I was relying on hosted API calls for everything, busy days kept hitting the ceiling. A self-hosted model has no rate limit at all. I can call it 100 times in a row and nothing throttles me. The second reason was cost predictability. A local model has near zero marginal cost per call. The electricity is basically rounding error. For routine, repetitive jobs with low stakes that runs dozens of times a day, that math is very different from paying a metered fee on every call. The third reason was privacy. Some of what I wanted the assistant to work with are my own notes, drafts, and local files. I was not comfortable routing those through a hosted API every time. Keeping that processing local meant I did not have to think twice about what I fed it. Those three things together were enough to make it worth the effort. The architecture in plain terms. I want to explain the architecture without turning this into a tutorial for a specific tool, because the exact stack matters less than understanding the shape of the thing. At the center is a small language model running locally on my own hardware. It is genuinely good at short, focused tasks. Summarize this, classify that, reformat this list, answer a question about this document. It is not trying to be a frontier model. There means to be a reliable, fast, and always available tool for narrow jobs. Beyond that model is a layer of scripts. Each script has one job. It calls the model, passes in some context, takes the output, and does something with it. Those scripts are wired to a scheduler that triggers them on a timetable. And the whole thing is reachable through a chat surface I can message from my phone or desktop. That is the whole architecture. A model, scripts, a scheduler, and a way to talk to it. What it actually does on a normal day. The main van paying done some distance, the tin kim phone and tin some. The morning, runs in digest. Your brains and sometimes which jobs completed, which failed, one send the calendar, none sends me a short summary. No searching, no deciding, just collecting some scan scan begin see man, fin some. Nun the jump, nun that the advantage then bend the no, nuts in files. The nothing PM, its skin form fin feeding, then none fin fiam. Then doing bin senin being the intenso. The Peter bin the room tin some. Rhythm tensam, 80 centimeter missy tinsam. Eu mina new boom to something testicle in the minty benidum. One is standing community mission people tin sit in some. Linden then pisti benin binting. Want to be direct about where this falls short, because the limits are real and you need to understand them before you build anything like this. A small local model is not as capable as a large frontier model. It is slower to reason, it makes more mistakes on complex tasks, and it has a much smaller context window. For the jobs I described, that is fine. Summarize, classify, retrieve, format. Those are short, bounded tasks and the smaller model handles them well. But there are jobs where it is not enough. long-form reasoning, nuanced writing, anything that requires holding the reasoning price balance, predicted restantinsum. The paid API handles the hard stuff. That split is the actual working architecture, and it took me a while to land on it. Reading the hard questions out, the reading logic is not complicated. When a request comes in, the script checks a few signals. It is unpicked in Tintidel, this something Tintin Dysense. Within Chuan designs is familiar plasm. Oankin Timid Thunder Pitipin, or Peminonti. This something Totan Santin, and uncontented sensen. The paradox shaped something select frequency, Winsensi, Contis Sipotin something Tintin, Lidis some non-tizzy, then something non-pintensions, Lifantintisansi. And the measured cost for the calls that go out is small, because I am only routing the genuinely hard ones. The local model handles most of the volume. The division of labor is what makes the whole thing practical. Keeping it alive is the real work. Here is the part nobody talks about enough. Getting the assistant running for the first time took maybe a day. Keeping it running reliably for weeks on end is a completely different job. The model process crashes occasionally. The scheduler sometimes misses a job. A script that worked fine last week breaks when something changes upstream. The disk fills up if you are not watching the logs. None of these are dramatic failures. They are just the normal entropy of a system with moving parts. And if you do not build for them, you come back one morning and nothing has run for 2 days and you have no idea why. So the reliability work is not optional, it is the whole point. The first version of my setup had none of this, and I learned that the hard way when I came back after a weekend to find it had been sitting idle the whole time. Logging and health checks. When handle this, it's boring, and that is exactly right. If every script writes a short log line when it runs, what it did, whether it succeeded, how long it took. Once a day, a health check script reads those logs and sends me a summary. If any job missed its last expected run, it flags it. If a log file shows errors 2 days in a row, it flags it. If the local model process is not responding, it flags it. None of this is fancy. It is just a small loop that checks the basics and tells me when something is off before it becomes a real problem. The logs are plain text files. Then septibriste sinin sat e antida, menzi man, because it quietly does its job every day without asking for anything. Automatic restarts. The other thing that makes a huge difference is making the processes restart themselves. If the model crashes, a supervisor process starts it again. If a scheduled job fails 3 times in a row, it alerts me instead of silently giving up. This is not a new idea. Process supervisors have been around for decades, but when you're building their personal system, it is easy to skip this step and just assume things will stay running. They will not. Everything that runs around the clock needs some kind of watchdog. Every process that runs continuously needs a restart policy in place. It takes maybe 30 minutes to wire up properly, and it saves you from the frustrating experience of waking up to a dead assistant 2 weeks after launch. The moment you add the restart policy, you stop thinking about the process staying up and start thinking about what it is doing instead. That is a much better problem to have. And what I would tell someone starting this, if you are thinking about building something like this, here is the most honest advice I have. Start with one job, not a general assistant that does everything. One specific job that you actually need done and that runs on a schedule. Maybe it is a morning digest, maybe it is a daily backup check, maybe it is one question answered automatically every day. Pick the smallest useful thing, make it reliable, and let it run for a few weeks before you add anything else. The reason is that the hard part is not the model or the scripts. The hard part is trust. You need to run a system long enough to know how it fails before you give it more responsibility. A system that does one job reliably and restarts itself is worth more than a system that does 10 jobs unreliably. Start small, prove it, then grow it. Make it observable from the start. The one thing I wish I had done earlier was build the logging and observability in from day one. We are at the other force of Gandinton, Wintintifem, Winatenson, Winimenson, Wimakin, Rehabilitation Prescriptions, Limpin Kunkin Timpimpi, Windows tiene tientin, Windows status quo. Rumling tem da dinas parte del shop, Windows ayavinstum. Windin tiun kamabin, win tienen sam. Windon tienen chimistim, Windian tin mainstum. Itim dan, some difference between itchitim, Butchers and tienchitim initiative kenzam. We can definitively vadisan dinitiantitim main seated. Knowing distinctive things without having to go check its system manually is a genuine improvement. Defy search is something I use more than I expected. Being the person ask a question about my own notes and get a fast answer is the kind of quiet productivity win that is hard to put a number on, but very easy to feel. The routing split between local and paid API means I am paying a metered cost that is small because only the genuinely hard requests go out. And from reliability to vlogs, the health checks, the restarts means I mostly forget the thing is running, which is exactly what we want from any piece of infrastructure. It does not demand attention, it just works. If you have been thinking about building an always-on assistant on your own hardware, I hope this gave you an honest picture of what it actually takes. It is not magic, it is a small model, a pile of scripts, a scheduler, and a healthy amount of boring reliability work. The payer-friendly is real. The stack is accessible if you start small and build slowly. Subscribe and follow along. Thanks for watching, and I will see you in the next one.